The fundamental principle of counting states that if we have A ways of doing something and B ways of doing another thing, then we have A multiplied by B ways of performing both actions. For example, we have 3 ways of choosing one of these letters, X, Y, or Z. We have 2 ways of choosing one of these 2 letters, A or B. That means we have 3 multiplied by 2 ways of performing both actions. In other words, we have 6 ways of choosing one of these elements from this set here. So the 6 ways of performing both actions comes from pairing off elements in both sets. For example, if we take the element which is A in this set here and pair it off with each of these elements in this set here, we get 3 ways to do that. And similarly for B, if we take this element B and pair it off with each of these, we get another 3 ways. So for each element in this set, there are 3 ways of pairing it with elements in this set here. So 3 ways for A, 3 ways for B, in total that's 6. Of course, we could look at that in reverse. For each element in this set here, we can pair it off in 2 ways with each element in this set here. So for example, if we choose this element here, X, in this set, we can pair it off in 2 ways with each element in this set. So X is paired off with A and X is paired off with B. We can do the same for Y. There are 2 ways to pair Y off with each of these elements. And finally for Z, another 2 ways. So for each of these there are 2 ways to select elements A or B from this set for each selection here. Since there are 3 selections, there are 3 by 2 ways to perform both actions. That is to choose a letter from this set and a letter from this set. How many different ways are there to arrange 5 distinct objects in a row? Now I'm going to represent each of the 5 distinct objects by a letter from the alphabet. So we have 5 different letters here. I'm using the first 5 letters from the alphabet to represent each object. So if you like, we have to place each of these objects in a certain arrangement. So each line here represents a position for each of these objects. So how many ways can this first space be occupied? Well, we can choose from any of these 5 letters or 5 objects. So for example, I could put B here, or I could put C, and so on. But there are 5 ways that I can fill this slot here, if you like. Once this slot has been filled, how many ways are there to fill the second slot? Well, once a letter has been placed here, there are only 4 letters left to choose from. So that means that there are only 4 ways to fill this second position. When these 2 positions are filled, there are 3 letters left, so there are 3 ways to fill this position. When the first 3 positions are filled, there are 2 letters left, so there are 2 ways to fill this position here. Finally, there's only 1 letter left, so there's only 1 way to fill the last position. So for example, we could have, one possible arrangement might be B, D, C, E, A. Here's another possible arrangement, and so on. The question is, how many of them are there? There's so many of them actually that I won't be writing them down. I've only written down 2 of them here. Well, we apply the fundamental principle of counting. There are 5 ways to fill this position, 4 ways to fill this position, 3 ways to fill this position, 2 ways to fill this position here, and finally 1 way to fill this last position. So the fundamental principle of counting tells us that the total number of ways of performing all these actions is got by multiplying all these ways together. Now I've stated the fundamental principle of counting for 2 possible things. We've A ways of doing one thing, B ways of doing another thing. Actually, we're doing 5 things here, and the fundamental principle of accounting will of course apply to doing more than two things. So what we actually do is multiply these together. Now this is given a special notation. 5 multiplied all the way back to 1 is denoted by 5 factorial. You see an exclamation mark, and you will see this button on your calculator. So it's a quick way to calculate this product here. So if you go to your calculator, put in 5, and on this calculator the factorial is denoted n factorial. So n is 5. So if I press this, I get the answer, which is 120. It's the same thing as 5 times 4 times 3 times 2 times 1. Well, I don't have to multiply by 1. We get 120. So there are 120 ways of writing out these 5 letters. And of course these 5 letters can stand for any 5 objects. We could be arranging 5 different books in a row, or 5 different blocks, whatever. Peter is arranging books on a shelf. He has 5 novels and 3 poetry books. He wants to keep the 5 novels together and the 3 poetry books together. In how many different ways can he arrange the books? Here I've let the letters A, B, C, D, E and E stand for the novels, and F, G and H stand for the poetry books. We know that there are 5 factorial ways of arranging 5 objects. In this case the objects are novels. We have that from part B. For the poetry books, we will see that there are 3 factorial ways. We have 3 ways to select the first poetry book. Say the first poetry book goes into this position, first position. 3 ways for that. Say the second position is here. Once one of the poetry books has been selected, there are 2 poetry books left, so there are 2 ways to select the second poetry book. And finally, to fill the last position, there's only 1 way. So these positions could be on a shelf. Well, they are on a shelf actually. 3 ways for this position, 2 ways for this position, and 1 way for this position. So we apply the fundamental principle of counting. Well, it's actually to more than 2 things. Here the fundamental principle of counting refers to doing 2 things. We're doing 3 things here. But we just extend this. We can extend it. What we do is we multiply these ways together. And we get 6. 3 factorial is 6. We want to find in how many different ways can he arrange the books. So first of all, let's assume that he keeps the novels to the left of the poetry books on his shelf. Of course, he could put the novels to the right of his poetry books, but first of all, let's consider this situation. Then I'll do the other situation. So there's 5 factorial ways that he can arrange the 5 novels, and we've already seen that that's equal to 120. There are 3 factorial ways that he can arrange his 3 poetry books, and that's 6. 3 by 2 by 1 is 6. So how many ways in total can he arrange his novels and poetry books such that his novels are to the left of his poetry books? Well, we just apply the fundamental principle of counting. So if there's A ways of doing something and B ways of doing something else, how many ways are there in total? A times B ways of performing both actions. So here, if you like, A is 5 factorial and B is 3 factorial. So the total number of ways of performing both actions is 5 factorial multiplied by 3 factorial. So that's 120 by 6, which is 720 ways. Here is the other arrangement. This is where he keeps his poetry books to the left of his novels on a shelf. So we apply the fundamental principle of counting here. There are 3 factorial ways to arrange the poetry books and 5 factorial ways to arrange the novels. So by the fundamental principle of counting, there are 3 factorial multiplied by 5 factorial ways of doing both actions, and that's 720. So the total number of ways that he can arrange his books such that the 5 novels are kept together and the 3 poetry books are kept together is 720 plus 720, which is 1440 ways.